will complete today, okay? That are wave behaviors and resonance and Doppler effect. And then as an online student, I always suggest you to check your email message. Make sure to check your message in your Genius. In each Monday, I'll send you a message, and if that Monday is a holiday, I'll send you a message in Tuesday. Okay, so always make sure to check your message, and also make sure to check your pace as well, and try to maintain your course pace. And then I have already sent you a message this morning, and then I have sent over there what is due this week. Okay, and then if you have any question, please let me know. And then if you are seeing this screen, it says Unit 1 waves, lesson are wave behaviors, resonance and Doppler effect. Please give me a thumbs up or any other reaction so that I can move forward. Okay, thank you very much. Now let's start with wave behaviors. Okay. So in this lesson, our goal is to learn about reflection, interference of both sound and light waves, refraction and diffraction of light waves. That is the goal of this lesson. And at first we'll define wave in 1 dimension and 2 dimension, and at the end we'll have practice from mastery test. Oops. Okay. So let's start with wave in 1 dimension. So when a wave encounters a boundary between medium and another medium, the factors such as speed, amplitude often change. This speed can change, amplitude can change. And then that wave can be either reflected or refracted from such a boundary, depending upon the boundary. And then when two waves in the same medium encounter, they interact to each other as well. Okay. Now let's define wave reflection. Whenever wave travel in a medium and hit a barrier, so we are talking about the same medium, okay? Hit a barrier, the wave inverts or turns upside down and start traveling in the opposite direction. That kind of phenomena is called reflection. Reflection. Let's look for one example. Let's suppose, take example of mirror. We have a mirror, and if the light wave incident in this direction, and then it cannot pass through the mirror, so it will reflect to this direction, like that. Okay? That is all about wave reflection. And these are the sum of the terms, okay? And then you can always take a note. Now let's go to the interference. When two waves travels toward each other, they overlap in a phenomenon called interference. Okay. And then that interference can be either constructive or destructive, depending upon the nature of the interference. If the two waves are in phase, that kind of interference is called constructive. And if they are not in phase, that kind of interference is called destructive interference. Okay. That is all about interference. So we talked about wave reflection and interference. Now let's go to the next slide. So do anybody want to volunteer and read like principle of superposition for me? Superposition. You can unmute and read that term, principle of superposition, and those two points for us. Now let's start with principle of superposition, okay? So according to the principle of superposition, the displacement of the resultant wave along at any point of interference is the sum of the displacement of the two waves. So we have to calculate the resultant displacement, we have to add the individual displacement of the two waves. Okay, that's how we'll calculate resultant displacement. And then crest is a positive displacement. That means if we have something like that, we'll consider that displacement as positive. And if we have a displacement like that, we'll consider this displacement as negative. Crest is a positive displacement, while trough is a negative displacement. Now let's talk about refraction. When waves encounter a change in medium, let us suppose the wave travels from air to water medium or water to air medium or any other one medium to another medium, they tend to bend in the new medium, and this phenomenon is called refraction. So as for example, let us suppose we have a water here, okay, the medium. So when the wave travels from air to water, this wave bend. This phenomenon is called refraction. And this is angle of incident. This is angle of reflection. So this is all about refraction. Think about bending phenomena of wave is called refraction. Now let's go to Huygens principles. Huygens principle, sorry. According to Huygens principle, every point on a wave front is a source of secondary waves that is spread in all directions with the same speed as that of the original wave. So we have a wave fronts like that, and it might produce like 2, 3, 4. It keeps going like that. And this wave front is the source of this wave front, and this is source of those two. This is source of other 4, like that. It keeps going in that way. So I'll pause here for some times. If you have any question about principle of superposition, refraction, or Huygens principle, please let me know. Or if you understood those concepts, please give me a thumbs up or any other reaction. Okay, thank you very much. Now let's go to the next slide. So this slide is about calculating resultant displacement when two waves interfere to each other. Yeah. Let's look to this diagram. In this diagram, those two waves are in phase. When their crests are aligned, that means they have exactly same displacement. When they aligned here, interference of the two waves that are in the phase results in a constructive interference. That means the displacement of both of those waves will add together, and then we'll get a new displacement. Okay, new displacement. That is the new displacement when two waves interfere to each other. Okay, now let's go to the next slide. Now this time we do have two waves. They have exactly same equal amplitude, but they are in out of phase. Okay, you can see this is a crest and this is a trough. Okay, and its displacement is positive, and displacement of this wave is negative, as a negative displacement. Now when those two waves overlap to each other, according to the principle of superposition, the displacement of the two waves at the point of interference is the sum of their individual displacement. We have to add those two. So this is This is that wave, and another one is that wave. And then when we add those two, we'll get a final wave like that. And this kind of interference is called destructive interference. That means think like that. They will displacement of this wave will cancel the displacement of this wave. So we'll get a wave like that. And that would be our resultant displacement. If the two waves are in phase, we'll add those together, and that is a constructive interference. And then if two waves are out of phase, then we'll subtract one from the previous one. Now let's talk about law of reflection, okay? And then what will happen in angle of incidence and in angle of reflection. According to the law of reflection, the angle at which a wave is reflected from a boundary is equal to the angle of incidence. So that means if we have a mirror, think about it, and then this is the incident ray, and then that incident ray, when it strike on the surface of mirror, it's reflected, and then the angle made by incident ray to the normal is called angle of incident. The angle made by reflected ray to the normal is called angle of reflection. And those two angles are equal to each other. According to the law of reflection, angle of incidence is equal to angle of reflection. Now let's practice some of the questions from this lesson, okay? Okay. So for each of those questions, I'll give you some time to answer. I'll launch a poll and then later I'll answer the question, okay? And then these all are questions are from your mastery test. Okay, read this question carefully and try to answer. I encourage all of you to take participation. Okay. The question is, which phenomena occurs when a wave encounters non-transmitting barrier? That means the wave cannot transmit from that barrier. Let me in polling. Thank you very much. The correct choice for this problem is the reflection of the wave with the same wave speed. Correct choice is C. Okay. So refraction only occurs when wave transmit through that barrier, like from one medium to another medium. Now let's go to the next question. This question is interesting. Two waves with amplitude of 105 units, so and 80 units arrive at a point in a medium simultaneously. And If the two waves are in phase to each other, what is the resultant amplitude of the wave? So we have to calculate resultant amplitude. Launch poll again. Answer this question. I'll give you some time and then I'll answer this question. Think about what should we do if the two waves are in same phase, okay? Same phase. Think about that. Either we have to add or subtract. Let me in polling. Thank you very much. I really appreciate it. The correct choice is D, and then most of you have answered it correctly on the 85 units. So let us suppose this is A1, amplitude 1, amplitude 2, and they are in same phase means we have to add those two amplitudes. That means resultant amplitude is A1 plus A2, 105 plus 80, that is 185 units. Let's go to the next slide. The question is, two waves with equal amplitude meet each other, resulting in a wave with zero amplitude. Which phenomena explain this resultant? Okay, and then try to understand those terms: diffraction, reflection, refraction, interference. Let me launch poll. Try your best and then I'll explain it again, okay? All of you have answered. Let me in polling. Thank you very much. Okay, let me explain this problem. The correct choice is D, interference. With equal amplitude meet each other. So that means this is amplitude with and the resulting the wave with a zero amplitude means they should be in out of phase like that. And then when they meet to each other, they overlap each other like that. And then their amplitude, you have to take negative amplitude for that. So that its final amplitude becomes, resultant amplitude becomes zero. And this phenomena is called destructive interference, okay? The diffraction is bending of light. Let me briefly, bending of light in corner, corner, let us suppose like if you speak in a cave or think about like pond, then the sound comes back to you louder. That kind of bending of light phenomenon is called diffraction. Reflection is simply the light hitting the barrier and then coming back to the same medium. And refraction is bending the light when it goes from one medium to another medium. Correct choice is interference. Okay, let me launch poll. The question is, a wave is incident on the surface of a mirror at an angle of 41 degree with the normal. What can you say about the angle of reflection? Think about law of reflection, okay? Law of reflection. Now let me make diagram for this question. So we do have a mirror like that. And then this is a normal angle of incident, angle of reflection. According to the law of reflection, what is the relationship between angle of incident and angle of reflection? Think about that. Let me in polling. Thank you very much. I really appreciate it. The correct choice for this problem is it is equal to the angle of incidence. According to the law of reflection, angle of incidence is always equal to angle of reflection. Angle of incidence is always equal to angle of reflection. Let's skip this question, okay? Okay. Now let's go to the next lesson. That is resonance and Doppler effect. So in this lesson, our goal is to learn about standing waves, resonance, and beats. And at the end, we'll go through Doppler effect. And then again, we'll review our mastery test. That is the goal of this lesson. Let's start with the definition of standing wave, resonance, and beats. And I'll suggest you to take note. Okay. So we have just gone through the definition of interference, and interference is the cause for standing wave. So a standing wave is the result of interference between two waves having the same frequency and traveling in opposite direction. Okay. Let me point out those information. Result of interference between two waves. So you can see here one wave in this direction, another wave is in this direction, opposite direction, and they do have exactly same frequency. And then when two waves travel in that way, opposite to each other with same frequency, that resultant wave is standing wave. Okay. And let's talk about different terms here. Standing wave frequency are called natural or resultant frequencies. Okay. And then the lowest frequency at which standing wave vibrate is called fundamental frequency of that medium or space. If you have pen and paper, take this note. Okay. Lowest frequency at which standing wave vibrates is called fundamental frequency of that medium. That's how we define fundamental frequency. Now let's go to this third point. Okay, let's skip that second one. In a standing wave, so we can see here standing wave, each point along the wave has a constant maximum displacement. So let us make one like straight line here. So at this point, we have a maximum displacement. Here we do have maximum displacement. Maximum displacement. And then nodes are the points that don't seem to move at all. And then or the point where the displacement is zero or minimums are called node. So let me make sure to make this diagram, okay, along with me. I'll write A, this point is B, C, D, D, E. Those all points are nodes, okay? Nodes, A, B, C, D, E are nodes, okay? And then you can see that it seems like those points are not moving, okay? And then displacement is zero. And then I'll write P, P, Q, R, S. So those points P, Q, R, S are called antinodes. P, Q, R, S called antinodes. And at antinodes, displacement is maximum. And there are several questions related to nodes and antinodes in your mastery test, okay? Is maximum. Here displacement is 0. Is 0. Yeah, I'll give you some time to take this note. Make sure to make that diagram and write those points, and then write the nodes and antinodes, okay? At antinodes, displacement is maximum, and at nodes, displacement is minimum. Okay, I'll pause here for some time. If you have any question, please let me know. Or give me a thumbs up if you understood, if you are following this concept. Yeah, thank you very much. Now let's think about what happens when two sound waves having slightly different frequency interfere to each other, okay? And then we know that whenever sound wave travel, we can see compression and rarefaction. So this is a compression, this part is rarefaction. And then when the sound wave of different frequency interfere, they are in phase at some point and out of phase at others. So we can see here at that points they are in phase because we can see compression here. Here they are out of phase. Here we can see destructive because here we can see rarefaction, and here we can see compression. And then when the different sound waves interference, the sound intensity rises at the point of constructive interference. So here at that part, intensity increases, and at destructive interference, intensity of the sound wave decreases. This periodic and repeated fluctuation in the intensity of sound. Sometimes the intensity increases, sometimes it decreases. This kind of fluctuation is called beats. Okay, that is the definition of beats. You can write that part, that this periodic and repeated fluctuation in the intensity of sound due to interference of sound waves are called beats. And there is one question related to the definition of beats in your mastery test. So you can write that definition. Now let's go to the next slide. Now let's talk a little bit about Doppler effect, and then we'll jump to the mastery test review, okay? So whenever we think about Doppler effect, think about, let me give you one example. Let us suppose you are walking or you are somewhere just standing, and then whenever you see a siren from the ambulance or horn, whenever that ambulance reaches nearby you, you see a like louder sound, and then when it goes away, you will see a lower sound. So this phenomena is simply called Doppler effect. Okay, and due to this phenomena, there is change in frequency of wave due to the motion of source and observer. And then, so It explains why frequency of sound from an ambulance increases when it moves towards you. Okay. Frequency of sound from an ambulance increases when it moves towards you and decreases it moves away. So I want to make one thing clear. Whenever frequency of sound increases at that time, you can write that wavelength decreases, okay? Decreases. And whenever frequency decreases, wavelength increases. Increases. There is always inverse relationship between frequency and wavelength. And this Doppler effect or Doppler shift is used by police officers to measure how fast is car traveling. They will measure frequency, wavelength, and calculate the speed of your car. Only thing you have to remember is this point, okay, here, or you can write that point. Frequency of sound wave increases when that ambulance or any source is moving towards you, and then wavelength decreases. And when it moves away from you, at that time, frequency decreases, wavelength increases. Now let's practice some of the questions. Okay. The question is, microwaves are electromagnetic waves used in broadcasting and telecommunications. When do these waves increase in frequency? Okay, let me launch polling. Okay. Try your best. When the frequency increases, when the source moves towards you, away you, think like that. Let me in polling. Thank you very much. The correct choice for this problem is when the source moves towards you. Okay. Give me 1 second. Okay, yeah, that's correct. The question is, when do these waves increase in frequency? The correct choice is when the source moves towards you, the frequency increases and wavelength decreases. Let's go to the next question. Now think about this question. What happens when a blaring siren moves away from you? Think in terms of wavelength, okay? Thank you for your response. Let me in polling and then answer this question. This question is a little bit tricky, okay? So whenever sirens moves, oops, siren moves away from you, frequency decreases. Think in that way at first, okay? Frequency decreases. And then frequency decreases means wavelength increases. Wavelength increases. So that means the correct choice is the wavelength of sound increases. Correct choice is C. Okay. Now think about this question. We talked about nodes, antinodes. Nodes are the points or position where the displacement is zero, and at antinodes, the displacement is maximum. Think about it and try to answer this question. Okay, both of you have answered. Thank you very much. Let me explain this, okay? Correct choice is 3. So nodes means the point where the displacement is 0. Those points. 1, 2, 3. Those are nodes. Okay. Those are the nodes. And antinodes are those, like one here and one here. So there are 3 nodes and 2 antinodes. Let me answer this question, okay? When two waves meet and result in resonance, how is the resultant wave different from the original wave? So it has a greater amplitude. The correct choice should be its amplitude increases.